So fractions, that's a way of saying fractions. Rational, ratio, one thing over the other. This is review number two now. It's all about fractions, basically. It's rational expressions, ratios, fractions. So this is something else that really they expect you to know coming in the door, but I know many are rusty. So we need to know well how to deal with fractions like that. So what do we do to deal with that fraction? How do we simplify that thing? Do you know the rules about it? Can I come in here and go, well, hey, this x cancels one of those x's, right? And 3 into 24 8 times? Like that? No? Is that not okay? Is that not true? Is that true? Not true. Yeah, it's completely false. It's completely not true. Now, why? Why can't you do that? It's because we still have the pluses and minuses. What I mean is, and here's the rule, the mantra I'm always saying to try to help students. Pluses and minuses in the world of algebra, x's and y's and numbers, are like glue. Have you ever shopped at Costco or Sam's Club, those warehouse stores, where you buy in bulk, right? We used to have 5 kids in the house. My wife would shop at Costco, buy in bulk, right? So what happens if you go to Costco or Sam's Club, one of those kind of places, and you reach up and you grab, a jar of spaghetti sauce? Is there ever just one? No, they're always plasticked to one other, or maybe in a group of 4. You got to buy a bunch, right? You can't take your scissors to Costco and just cut the plastic and say, thanks, I just want one. They won't let you have just one. Well, that's what pluses and minuses are like in algebra. Pluses and minuses play that same role. They glue things together, and you can't break that glue bond. That's what that rule will serve you well in so many situations. So pluses and minuses are like glue. They glue things together, make them a package deal where you got to do all of them or nothing. You can't break the package. So now, what am I talking about? So because these are glued, right? The minuses and pluses are the glue. And these guys, the 8x and the 24, are glued together. I can't break and say, well, I just want to take just the 3 into the 24. No. He's part of a package deal, and so is the bottom. So we can't do that. We can't do that. So what do we do then? If we can't do that, what do we do? We do what we just spent that whole last review section doing. What do we do with just forget about the bottom for a minute. What can we do with just that? We can factor it out of GCF. Yeah, take out what's in common. What do those share in common? They share x. Take the x away from them. What are they left with? X times what would go back to x squared? X. And x times what would go to minus 3x? Minus 3. Is that good so far for that factoring on the top? Now on the bottom, it's the same thing, huh? What do 8x and 24 share in common? 8. 8 goes into both of them, huh? So now, pull the 8. Divide the 8 out of both of them. 8 times what will go back to 8x? X. And 8 times what will go back to 24? Minus 3. See how we just factored the top and the bottom? That what we spent the whole last section. This is why factoring is so important to all the rest of our course. Because we factor all the time. So I just factored. Now, can I cancel these x minus 3s? Yes. What about my pluses and minuses are glue, and they make a glue, and you can't break the glue bond Costco thing? I'm buying the whole package. That's fine. Costco will sell you the whole package, right? I took this. That's what I'm saying. Pluses and minuses make things an all or nothing deal. But I took the whole package. I took the x and the 3, glued together, whole thing, and walked out of the store. That's fine, right? It's fine to take the whole package. You just can't take one part or the other part, right? You can't break up the package and say, thanks, I just want this part of the package. You with me? So plus and minuses glue them together, which makes the package all or nothing. But I took the whole package. That's fine. So what are we left with? Just the x over 8. We're done. So that big old fraction simplified to just be x over 8 after we factored. Is that good? Yeah. Want to try number 2 there? And how do you, now the top just stays 12x. What about the bottom? What goes into both of those? 3x, right? And now put in the inside whatever they have in common. 3x times what goes back to 6x squared? 2x. Does that make sense? 3x times 2x is 6x squared. Out front numbers multiply, powers add. And 3x times what will go back to minus 3x? Negative 1. We good there so far?
So when it's a single number at the top, you just leave it alone?
Yeah, because, there's nothing we can do with just that. Yeah, it's just one term on the top. Yeah, good question, good clarification. Yeah, that's just one term on the top. We just leave that. Okay, now, can I cancel anything? Remember now, things that are plus or minus are all or nothing. You have to take all, like if I want to do anything with the 2x minus 1, then I have to take it all or don't touch it, right? That's the Costco package deal, right? But I don't really care about the 2x minus 1. What am I going to cancel?
3.
Yeah. The x cancels the x, and the 3 goes into the 12 4 times. Is that okay to do? What about the Costco package thing? Those are individual items, huh? They don't have pluses and minuses between them. They're shopping at Save Mart. You can buy just one. It's fine. Does everybody see the difference? Things that are not plus or minus, just do whatever you want. No problem. So that's just fine. 3 goes into 12 4 times. Right? I just divided on that. And just canceled the x's because they're not part of a package. But anything with a plus or a minus, that's a package. That makes it all or nothing. So what does that leave us then? 4 over 2x minus 1. You don't need the parentheses on the 2x minus 1 anymore because there's nothing to separate it from anymore. The 3x that was next to it has gone away. So that's it. We're done. Does that make sense? So we factor and then we cancel. Now, hey, how about this, guys? Could I, you can tell by my tone the answer is no, huh? Can I cancel 2 into 4? No is the answer. Why not? Why can't I cancel 2 into 4 2 times like that? Because the 2x minus 1 is a package. You getting the thinking? Anything with plus or minuses is all or nothing. That 2x minus 1 is saying, look, I'm a package. If you want any of me, you take all of me or you take nothing. Right? All or nothing. I'm a package deal. Things plus or minus are a package deal. 4 over 2x minus. So it just stays as it is because we can't cancel the whole 2x minus 1, so we can't take any part of it. It's a package. We're just done right there. All right, let's try number 3. Same thing. Basically, all these problems are factoring problems. Huh? In the end, it's just more factoring. You just factor the top, factor the bottom every time. So on number 3, factor the top and factor the bottom. It's more and more factoring practice. Getting used to these new rules. Yeah, why can't I just go y squared cancels y squared? Package. Remember? This y squared minus 64 is saying, I'm a package. You want some of me? You take all of me. You don't just take my y squared. Right? That's why we have to factor. Does everybody see that? Pluses and minuses, all or nothing. Package deal. So we can't just do that. Really good question. So you have to factor. Yeah, so just go on and factor the top. How's that top factor? 2 terms. What's the only thing we ever try for 2 terms? It's on the board still. 2 terms? Double. You should look. It's all we ever do for 2 terms. It's double or nothing. So is that a double?
Yeah.
Absolutely. It's YY and 8 times 8, huh? Double. 2 terms. YY, 8. So do that one. And then on the bottom, what are you going to do first on the bottom? You're going to do what? Take out a common factor of 4, huh? 4 goes into all those, yeah. So just keep going. So we go, okay, 2 parentheses. Y is in the front, 8's in the back, 1 plus 1 minus. Remember how the double works? Y is in the front, 8's in the back, and positive times 8 will make negative 64. Now on the bottom, we're going to have to do 2 steps. I'll do the first one here. Take out a 4, leaves y squared minus 6y minus, 16? Use your calculator there. That good so far? I took out what was in common. That's always the first step on factoring, right? If all the terms have a number in common. You do that first. And then you got to finish from there, don't you? So this 4 is going to stay there. But then the 3 terms here, what do we always do with 3 terms? We break them into 2 parentheses. So break those into 2 parentheses. Remember how it works? What multiplies to be y squared? Y times y. What multiplies to be 16? What's that? What times what is 16? 4 times 4 or 8 times 2? Yeah, we want the 8 times 2 because we have to get the 6 in the middle, don't we? See that? Question? In common, I put it in the front, and then I put the new numbers. It changes the numbers, doesn't it? And then, what multiplies 16? 8 times 2? 8 times 2. And how do we get the middle number of minus 6? Sign in the middle goes on the bigger. Minus 8 plus 2. That'll make minus 6, won't it? You okay down there on the factoring? Now, where do we go from here? Now that everything's factored, are there any matches top and bottom? Yeah. So that's fine. I took the whole packages, so that's good. And that's all we can do. So what's left on the top? Just y plus 8. You don't need parentheses on it anymore. There's nothing to separate it from. On the bottom, 4 and y plus 2. And we're done. That's as far as we can go. Does that make good sense? Why can't I cancel out those y's?
Because they're packaged.
Part of the package, right? The y plus 8 on the top says, I'm a package deal. If you want any of me, you buy all of me or none of me. You can't take just the y or just the 8.
Why can't you multiply the 4 against the y plus 2 and then cancel those out? They'll be left 4.
Do what? Say that again?
It's like multiply 4 times y plus 2.
Right. So we'd have y plus 8 still on top, and then multiply that 4, we get 4y plus 8.
And then cancel out the y plus 8.
Cancel out the y plus 8 and the y plus 8?
Yeah.
Because what is this for? Good question, really good question. This 4y plus 8, the whole thing is a package. And he's saying, if you want to mess with me, you buy all of me or none of me. And we're trying to leave the 4 behind.
All right.
Again, it's the same issue, isn't it? It's the package issue. It's all or nothing with things that are plus and minus. Does that make sense? Why did math make up this weird rule about Costco plus or minus package deals? It seems like they're just trying to make things hard, doesn't it? Is that what's going on? There's really a conspiracy. They took me in on it as a baby and gave me the math knowledge I'm supposed to force on other people. No, it feels that way. Some I know students have shared with me they feel that way at times. Math is just simply following the truth. Let me show you, for example. What if you had 2 plus, 6 over 6? No, that's not a good example. How about, I'm having trouble coming up with a good example. How about 2 plus 2 over 2? Yeah, right. No, that's a terrible example. I'm still having trouble. All right, here we go. What if you had 2 plus 8 over there? I got to go now. All right, now, what is that? All fancy math rules aside, what is that really? Really, 8 plus 2 is what?
10 over 2.
10. It's really 10 over 2. And what is 10 divided by 2? It's really 5, isn't it? All fancy rules aside, that's a 5, isn't it? So, would canceling the 2's be okay?
No.
Clearly not. Math's not just making stuff up. It's just saying it's wrong. See with numbers? You cannot, because that plus sign on the top, I'm giving you a way to remember the rule. There's not really a Costco rule. That's just my little way to help you. But you see, the Costco rule is true. That's just following what's true. If two numbers are added, you can't take one of them. Look, you're saying that's 8 now. It's not 8, it's 5. See how that's just not right? Now, Mr. Harney, if I was you, I'd be thinking, now, Mr. Harney, you're saying that the plus sign is the problem, or minus? Yes, I am. And if that was times instead of plus or minus, that it would be okay? That's exactly what I'm saying. It's plus or minus. Have you noticed? Times is no problem. Plus or minus is the glue issue. So, Mr. Harney, you're saying if that was times, then you could just cancel those 2's? Exactly, right? Isn't it true? Look at it. What is it really? Forget all the fancy rules. What is it really? What's 2 times 8 on the top really? 16. And what's 16 divided by 2 really? 8. So is it okay to cancel the 2's?
Yeah.
It is. You see? It's just what's true. It's harder to see the truth when there's x's and y's instead of numbers. But an x is just a number we don't know currently. It's the same truth. Right? So pluses and minuses wreck algebra. That's the other thing I'm always telling my algebra students. Pluses and minuses make everything hard. Pluses and minuses are the glue that wrecks everything, makes all the hard rules because things are packaged together and you can't mess with them. But times is no problem. Just do whatever seems natural. It always works with times. But pluses and minuses, no go. You can just see it's not true. All right, back to the problem. So, questions on number 3 then? Is that good? Let's go to number 4. Guess what we're going to do? Can I come in here and go 7 into 63? No. Costco, they're all glued together, top and bottom. So you know what? Factor, right? You see how factoring breaks things into little packages so we can cancel? That's why we're into factoring. It helps us. So factor the top, factor the bottom. So on the top, 3 terms. What do we do to factor 3 terms? All right, I'll jump in and help. So on the top, it's always 2 parentheses. X is in the front to be x squared in the front, right? What multiplies to be 63? 7 and 9. Now sign in the middle goes on the bigger. Which number is bigger, 7 or 9? 9. So he takes the same sign as the middle, doesn't he? The sign in the middle goes on the bigger. The other one's minus. 9 minus 7 is plus 2, and they multiply to be negative 63, don't they? Good so far? Getting a little more comfortable with that kind of factoring? Now, what are we going to do on the bottom? Reorder them. They're out of order. We don't want the x's in the back. It's supposed to be highest power of x to lowest. They're out of order. So this, now remember when you switch things around, can I go like this? Just switch them. No. That's wrong. Why? I didn't take their babies with them, right? Whatever sign is in front of somebody, that's his baby. You got to take it with you wherever you go. So that minus that's in front of the x, that has to go with it. And what's in front of the 7? Nothing, so plus. Right? So remember, we have to reorder from highest power to lowest. In this case, it's just x and no x. Okay, and then not only that, when you have a negative 1 in the front, what are you supposed to do? Take the negative 1 out, right? Factor out the negative 1, and that changes the signs on the inside. Negative 1 times what will go back to negative x? X. And negative 1 times what will go back to plus 7? Negative 7. Right? Good. Now it's factored. Any matches top and bottom? X minus 7, x minus 7. That's fine to do. I'm buying the entire package, aren't I? That's okay to do. I'm not breaking up the package and taking only part of it. The entire x minus 7 package. So what does that leave us? X plus 9 on the top and, negative 1. We can't leave a negative 1 on the bottom. I forgot about that. We have one more step. Right? We never leave a 1 on the bottom of a fraction, do we? So what do you do with it then? Well, you can separate that. That's x over negative 1 plus 9 over negative 1, right? You can write them each separate over negative 1. And then what happens there? So x over negative 1, what you tell me, guys, what is, I don't know, like 3 divided by negative 1? It's just negative 3, right? Right? It's just a positive over a negative is negative, and 3 divided by 1 is just 3. Let the signs and the numbers be separate issues for you. So 3 divided by 1 is just 3, right? And positive and negative makes negative, doesn't it? Well, it's the same thing here. Anything divided by 1, that doesn't do anything, does it? X divided by 1 is just x. But what's the sign? Positive x over negative 1? Negative x. And what's positive 9 over negative 1? Negative 9. There we go. Did you see those last couple of steps? They were a little tricky. So one more time. All I had on the bottom was a negative 1. Right? So both the x and the 9, the x plus 9 was over the negative 1. So I put the negative 1 under each one separately. And then anything divided by 1 is just itself, right? Just like a number. 3 divided by 1 is just 3. X divided by 1 is just x. But watch the signs. You know, 1 negative is negative. 2 negatives would make positive, right? So positive x over negative 1 is negative x. Positive 9 over negative 1 is negative 9. And we're done there.
Is that the way you want it, or do you want to take that negative out?
No, that's great. Yeah, you don't have to factor any further. That's fine. You could put a negative out, but it's not required. Math Excel will take that just fine.
So if it had been x minus 9, then the answer would have been negative x plus 9, right?
Yes, correct. Correct. That's right. All right, we better keep moving. Number 5, bunch of factoring. Now, the x alone here and the 8x8, those don't need to be factored. Those are good. But factor the parts that have pluses and minuses, those are the ones that need to be factored because they're the package deals. So factor those other two. And then we'll start cross-canceling once we have them factored. So how do we factor 4x plus 36? Take out a 4. Leaves x plus 9, right? They have a 4 in common. They share a 4, right? 4 goes into both of them. Keep going. And how do we factor x squared minus 81? Yeah, what do we do for 2 terms? It's 2 terms. Double, double, huh? That's double, double. This is x, 9 times 9. So you know, 2 parentheses, x is in the front, 9's in the back. 1 plus 1 minus. Because positive 9 times negative 9 is negative 81. So now it's all, see, the hard work is the factoring, huh? Factoring is super important to get good at. If you're going to go the way of STEM, absolutely. I remember my own 2 daughters back when they were taking pre-calculus or trig or pre-calc, I can't remember, it's been a couple of years now, doing homework at the table and saying, Dad, I just hate factoring, I can't factor. I said, well, if you're not going to factor, then don't go on in STEM, because you absolutely must learn to factor. It just takes practice, but a lot of practice. So the x plus 9s cancel, like that. Right? Picking the package there. And what else? Can I cancel anything else? Anything else we can cancel? Can I cancel this 4 into 8? Why not? Is it part of a package? No, it's totally fine to do. Everybody see that? He's not got a plus next to him. He's not part of it. You getting this package, no package distinction?
So what do we do?
Things that are times, you can cancel. Because I know you might think, well, no, he's got to have an x. No. I'm not looking. I'm just taking the 8. I'm just taking part of the package. Well, it's not a package. Just part of it. It's just save mark. I can buy just one. Right? And what about that x up on the top with this 8 down here? Yeah, he'll cancel, leave 7 of them. See what happened there? One of the x's on the top canceled one of the x's on the bottom, leaving 7x. Because x to the 8th meant 8 x's, didn't it? So that one on the top canceled one of the 8 on the bottom, leaving 7. Because they're not packages, are they? They don't have pluses or minuses next to them. See the difference? So what are we left? I don't see it. What is left standing on the top? So just a 1. Yeah, there's nothing left on the top. So, but you put a 1, right? When I say right, I'm meaning, think about normal. Well, what is 2/6 the same as? 2 goes into 6 3 times. What do? You don't just write blank thirds, you write 1/3, don't you? That's what we always do when the top cancels, huh? I'm not doing anything different or new. Whenever the top of a fraction cancels, we put a 1. And then what's on the bottom? 2x to the 7th, x minus 9, right? This 2x to the 7th and the x minus 9 are left. Everybody see what happened there? At the end, everybody see what went on? 4 went into 8, and the 1x on the top canceled one of the 8 x's on the bottom, 27. That makes sense? Is that okay? You know, it maybe it'd help if I wrote it out. That x to the 8th, right there, you know, x to the 8th, you know that means 4, 5, 6, 7, 8 x's, huh? And you don't have to do this, but I just want to be super clear. And this x canceled one of these guys. No packages there. Nobody's plussed or minused. They're just timesed, so you can buy just one. It's fine to do. Everybody see the difference? So that's why it left x to the 7th on the bottom.
Would it have been incorrect if I multiplied across first and then chop it down?
What do you mean by multiplied across?
So we canceled out the x plus signs, right? And we're
Right.
left with 4. That's 4 times x is 4x, right? Put it together.
I'm sorry, where are you getting the forks?
I did this number here.
Oh, I see. Yeah, no, that'd be fine. Yeah, at some point you got to cancel. Yeah, at some point it's going to cancel. That'd be fine to do that first, but then it's still going to cancel on that. Good on that. All right, let's try number 6. They're getting uglier. So it's more factoring. Take out what's in common, top and bottom. That one's kind of ugly. See this guy right here? What are you going to have to do with that piece? He's out of order. X's shouldn't be in the back. Reorder him, remember? Got to be highest power to lowest. Can't have X's in the back. So you're going to have to reorder him and then factor. So switch his order. We always want the higher power, the X in the front. So 14 goes into 98, doesn't it? Just try it in your calculator. I'm assuming, just by looking at it, just take 98 and divide by 14. So 7 times? Okay, great. So then this is going to be 14. We can factor out x minus 7. Is that right? Because that 14 times x is that, and 14 times 7 is 98. And then minus 2x there. Is that good? So that's just, just big number. Just use your calculator. Now on the bottom, we have to reorder. Let me just do it right here. Remember when we reorder things, we take their sign with them, the sign that's in front of them. That's their baby. You don't go anywhere without your baby. So minus 21x plus 147. I just reorder it, right? We want the x's in the front always. And then that can be factored. Probably 147 is divisible by 2, isn't it? 21, isn't it? Yeah. Doesn't 21 go in there? 7 times, huh? So put the minus 21 in the front. Minus 21 times what? X. And minus 21 times minus 7, right? Because negative times negative will go back to plus 147. Everybody see that? All right, now we have it factored, so let's cancel. Now remember, anything with pluses or minuses is a package deal, but anything that doesn't have pluses or minuses, we can just cancel one by one. So x minus 7, x minus 7. What else can we do?
Negative 2x.
Yeah, let's decide, by the way, let's decide the signs right now. That's pretty easy, right? We have a negative times a negative. What's our final sign going to be? Positive, yeah, and then just forget about the signs. Right? It's just going to be two negatives multiplied. It's going to be positive, yeah. Yeah, now what else can we do? There's a lot of ways you could do it here. I'll write it out more carefully. It's 14 over 2, and it's 4 over 21. All the x minus 7s and the negatives are gone, huh? Because two negatives made positive, and the x minus 7s have dropped out. There's a lot of good ways you could finish it. Maybe I'll show you a couple different ways. Basically, you can cancel anything under a bar with anything over a bar. Straight up and down or diagonal. It's good either way. Doesn't matter. So there's a lot of options. Yeah.
What happened to the x that was on the 2?
Oh, thank you. I just lost it. Yeah, that's there too. Thank you. Yeah. He just vanishes. Yeah. Yeah, thank you. But he's not a package deal, is he? So we don't care about him. The 2 is not married to him, is not glued to him, right? That 2 is independent. I just switched the analogy from Costco to marriage. But you get the idea. It's not a package deal, right? That 2 and x are separate. So don't let that x bug you in any way. Just take that 2 and do whatever you want with it, right? So the 2, for example, you could go into 14 7 times. Or I could have gone 2 into 4. It's good either way. And now what else can we do now? Anything above with anything below. Like the 7 can go into 21 3 times. What's left? 4 on the top, 3x on the bottom. That's our answer. Want me to do that again?
Oh, yeah.
Let me do that again. I'll show you one more time. So 14 over 2x and 4 over 21. Basically, you can cancel anything under the bar with anything above the bar that have stuff in common. Like I could go 2 into 4 2 times. I could go that way first. That's fine. But be clear what's gone and what's still there, right? The 2's gone. The 4's gone. Now what can I do? 14 and 21, what do they share in common? Yeah, because 14 doesn't go into 21, but 7 goes into both of them, huh? So divide them both by 7. Divide by 7 leaves a 2. Divide by 7 leaves a 3. Good. I just divided top and bottom by 7. This is just another way you could go. What's left now? Can anything else cancel top to bottom? What do I have on the top right now? 2 2s. What do I have on the bottom? A 3 and an x. There's nothing more in common, top to bottom. So just multiply them. 2 times 2 on the top. 4. 3 times x on the bottom. Same answer. See that? So it doesn't matter how you do it. Just cancel bottom stuff with top stuff any way you want. And when you're all done, multiply what's left over. 4 over 3x. Which means this big old ugly mess is the same as just 4 over 3x. It cleans up that much. It simplifies that much. So we're doing all this because in science things, sometimes you have big messy expressions like that and you need to clean it up. So 4 over 3x. Is that good? Does that make sense? Let me squish it in up here one more time. So right here it became 14 over 2x, 4 over 21. One more time. Like I could go 2 into 14 7 times, and then I could go 7 into 21 3 times. What's left? 4 on the top. Right, that 7's gone now. That 14's gone. That 2's gone. That 21's gone. 3x on the bottom. All right. So number 7. Number 7 does not look user-friendly, does it? Number 7 is a fraction over a fraction. How do you deal with a fraction over a fraction? I think you might know more than is in your mind right now. If I refresh your memory in a couple of ways, think about if you take 10 and you divide it by 2. What do you get? 5, of course, huh? So what if? So in other words, 10 divided by 2. You can write that either way. Same thing, right? 10 over 2, 10 divided by 2, same thing. Either way, it's 5, right? That you know, right? Now, think with me. What's half a 10? What's 10 times a half? What's half a 10? That's also 5, isn't it? So pause with me for a second and observe a truth. Do you see what's true there? Taking 10 and dividing by the whole number 2 is exactly the same answer, as taking that same 10 and instead of dividing by the whole number 2, timesing by the flip of it. 1 over 2. Huh. Dividing's upside down multiplying, in other words. Right? Dividing by 2, taking 10 and dividing by 2 gives the answer 5. Same answer you get if you take that 10 and multiply by the upside down of 2. 1/2. Half a 10 is the same answer, huh? So in other words, dividing by a number like 2 or any other number is the same thing as multiplying by its upside down, what we call reciprocal, a fancy word. Right? Dividing is upside down multiplying, isn't it? Of course. Dividing is just upside down multiplying. So anytime you're dividing by something, instead you can multiply by the upside down, and that's easier. Multiplying is easier than dividing. That's why we care about this observation. When you're dividing by a number or any letter expression, instead you can multiply by the upside down, the reciprocal, and you get the same answer. Dividing is upside down multiplying. Okay, so let's use that on this big ugly problem. So coming back over here, we've got this big old fraction divided by this other fraction, right? Well, we just observed that dividing by something is the same as multiplying by its reciprocal. It's upside down. So I take this numerator here, and I multiply by the what? Upside down of the other one. Did y'all see that? I flipped it, didn't I? I took this guy and I flipped it upside down. Dividing by a fraction is the same as multiplying by its reciprocal. Dividing is upside down multiplying, as we observed with the 2. So that's all this means. This is just a big fancy multiplication problem where you flip the bottom, huh? Just grab the bottom and flip it up. Can you take it from here now? Now that it looks a little bit more normal? Just a bunch of factoring, isn't it? 4 factoring, or 3. You don't need to do anything with this 4x because he's only one term, right? Why do I say one term? I'm really not into math language. I don't use much math language. I make up my own, as you saw, double and stuff, right? So there's one word, though, that is super helpful. That is terms. Terms, because that'll help you know what to do. Terms are things separated by pluses and minuses, like the Costco thing. So that's how you should be looking at math, at algebra. This is one term. You might think, well, no, that's 2 things, Mr. Ernst. It's 4 and x. Yeah, but when I say term, I mean they're not separated by pluses or minuses, huh? If it was 4 plus x, that'd be 2 terms. But 4x, that's 1 term. So 1 term on the top, 2 here, 2 here, 2 there. So 1 term, we don't factor 1 term. He just stays 4x. But all the other ones, we're going to factor. So factor all those other ones and then cancel what you can. So all those other ones, so take out what's in common. So you got to factor first, right? 5x and 30, 5 goes into both of them. Yeah, 5 in common. 8x and 72, 8 goes into both of them. making any sense? How do we factor x squared minus 36? We've done that one a few times. What's that one? Double, double.
6, 6.
XX, 6, 6, right? X times x, 6 times 6. You know how to do that one, right? 2 parentheses. X is in the fronts, 6 is in the backs. And the other ones are just take out what's in common. What goes into 5 and 30? 5 does. And what goes into 8 and 72? 8 does. Take out an 8, right? Is that good? Are we okay with all that factoring? See, I took out what's in common, a 5 on the top. That would multiply back. I took out the 8 on the bottom. And now, am I losing you? Questions to there? Now what can we cross cancel? Yeah, this and this. Remember, it's okay that they're far away. Anything over the bar with anything under the bar is totally fine. So they cancel, and that's all. Oh, there's one other thing. Yeah, the 4 and the 8, because the 4 is not part of a package, right? The 4 is not plussed or minused with anything. So the 4 is a loner, and so's the 8. 4 goes into 8 2 times. Huh? The rest must stay. So what are we left with? What's left on the top? What's not crossed out on the top? 5 and x. And on the bottom, what's not crossed out? 2, x minus 6, x minus 9. There it is.